Start recording. Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream on Twitch. No engines and no libraries. It's just us here programming. And today we are going to do a little font work. Now we already did work to extract fonts in our asset processing utility. And we actually showed how to use a library there as well. So we actually have two paths in our asset packer, one that doesn't use any libraries in case you want to go full no library, and then another one that shows how to use Sean Barrett's excellent font library in case you would like to use that instead. We did that in honor of his birthday, and also because a lot of people ask me if there was a library to use, what would it be? And Sean's libraries are always the answer to that question. So we did all that, and we've got that in there, but all that does for us, whether you use a library or not, is it only gets out the information about the glyphs. What we haven't written yet in either path is any way to get out the actual metrics for the text, such as how to space letters between each other, called kerning, which we discussed on the introduction to fonts, or where the baseline is, for example, like how the font should sit on a horizontal line, that sort of thing. So we haven't done any of that work in either the path that I showed how to use a Sean library, or in the path that uses no libraries, where we call into Windows to extract that information. And so what we need to do today is we need to start working on that so that we can augment our asset pack file to include this information so that when we process a font for use in the game, it will have the metrics necessary for the engine to then align the font in a sensible way so that it looks like what the font designer intended when they created the font. And, you know, it will have a relatively attractive appearance on the screen as a result. That's the goal anyway. So if you haven't already watched the introduction video to fonts, you probably want to do so because I'll be referring to things like kerning and I'm going to expect that you know what they mean. I'll try to give a brief refresher where appropriate, but you really probably want to know some stuff about fonts. Not too much, you don't have to be a typographer, but you just want to know some basic terms as we go. So we're going to be doing coding today for sure. So today's day 168. If you would please, if you're one of the people who pre-ordered the source code on handmadehero.org, please unpack day 167 source code into a directory. That is the source code that I will be starting with today. So if you would like to follow along at home, that's the way to do it. So here we go. What I'm going to do, which is a little bit odd potentially, is I'm not even going to open up the asset processor just yet. And the reason that I'm not going to open up the asset processor just yet is because, again, like I say many times, always write the usage code for something first if you can. That is a classic thing that we're going to see right now. Basically, I mean, I kind of do know what I need for fonts because I've written them so many times before, but on Handmade Hero, even when I know what I'd already write, I try to still show you the way to go about it properly so that when you're doing it yourself, and maybe you haven't done this before, you're tackling a new problem, which I still do every day. I oftentimes tackle new problems. I want to make sure you see the correct way to approach a programming problem and don't just see me sort of typing out stuff I already know how to do, right? Which is not particularly useful. So in this case, I know that I need information about these fonts to line them up, right? And yes, because I've done font programming before, I could probably guess exactly what those things might be and how I might need them, and I could go into the asset processor and just do it. But if this was your first font system, you wouldn't know that. And so you'd be left in a situation where you're like, I don't even really know what data I should store with the fonts to do this alignment. And so when you find yourself in that situation, that's when I always say, make sure you write the usage code first, because the usage code will guide you. So what I'm going to do is I'm going to go in and write the actual routines that display text on the screen as if we had the information necessary to line them up. And by looking at how that code comes out, I will then be able to essentially reverse, I will be able to like back solve, right? For the information we'll actually need in the asset file and how I want that information structured, right? So that's pretty handy. And I say that a lot. That's what I mean when I say always write the usage code first. When you find yourself in a situation where there's one side of the code that you do know how to write, and really, I guess I should say, it's kind of a more general statement even than always write the usage code first. What I really mean is always write the code you know how to write first, right? It sounds kind of obvious when you say it, but most people actually don't do it. It's weird. They tend to like if they know how, if they have something that they're going to go implement, they tend to like start writing the interface for it first or something, without writing the implementation code, and that leads to problems. If they have something where they know what the interface is that they actually want, but they haven't written anything to it yet, they'll go do the implementation for it. It's weird. Like you get into these weird situations where it's like you write the wrong side of the code. And someday I should probably try to figure out a good way to like formally explain exactly the process that you want to go through. But the long and short of it is, when you're about to start coding something, if there's a mystery, if there's a piece with a question mark over it, right? Don't start there. Start at the place you actually know and crawl into, like push into the question mark. That will allow you to make sure that you're on firm footing as you go in there, rather than starting in the question mark and working your way out. Because that is really what causes a lot of problems, because then you find that you've done something that doesn't really fit the needs of the system that you had, because you had all these known things that you know that it had to work with, right? So that's what we're going to do here. We know that we have to write this stuff. I don't know what data to store, so I'm just going to go write the functions I know that I want for like display some text on the screen. I'm going to write them in the way that I want them to work, and then I'm going to see what falls out of that in terms of the data and the functions that the asset system should provide for getting that back to me. So let's start with a pretty simple task, something that should be very easy for us to do, right? Right now, if you look at Win32 Handmade, you'll note that we have some stuff in here. In fact, I don't even remember where it is. We did it a long time ago. But we had these little debug timers, right? You can see them here. And the way that those debug timers worked is, if you had Handmade internal defined, then these debug timers would like do a bunch of stuff. That's not actually the one that I'm thinking of there. That is a debug timer. That's not the one I meant. I meant those little debug timers. Let's see here. Where are they? You know the ones I mean. They were like cycle counters. These right here, right? You see these guys? So we had some debug cycle counters. It was a really very basic system. I was just showing some really, really rudimentary ways you could time some code, right? And we didn't have any way to display this at all, so we just had the Win32 platform layer dump it out to the debug port, right? So what I would like to do is I'd like to make a way for us to display those debug counters on the screen, right? Something very simple so that when we open the game, we can see those debug counters updating on top of the frame as we go, right? Something that would be a very straightforward part of what we want to do in terms of debug display. That's very simple. So if I take a look at how these are being displayed right now, we can kind of see debug cycle counter. Here is how that gets dumped out, right, at the moment. And so what I want to do is kind of start down that path. And I want to imagine that we had a way to print this out. Now there's two parts of printing this out that we have to write. One of them we care about right now, and one of them we don't. So the two parts of it are, first of all, we need a way to actually put fonts on the screen. That's the part we care about. And then there's the part about how to actually convert numbers, like numerical values, into text. And that part we don't care about quite yet. We will care about it once we actually want the debug counters to actually start printing. But for the moment, we don't care about that because we're working on the font part of things first. So what I want to do is I want to take this routine, right, that you can see right here. And what I want to do is I want to go into our game, and I want to start printing. I want to start imagining, I guess, since I can't quite print it yet. I want to start imagining that I was able to print this out to the screen. And so what I'm going to do is I'm going to make a little function here in handmade.cpp. And again, handmade.cpp is kind of just our dumping ground for things that don't have a home yet. Things kind of grow in Handmade CPP, and then we move them out into their own files sort of as we determine what forms a coherent system and what stuff we want to think about together, right? So if I have this here, I'm going to just call this overlay cycle counts or something, or cycle counters. And so the overlay cycle counters function, obviously it needs to take the game memory so that it can loop over these things. And when it loops over these things, we don't have the ability of doing output debug string because now we're not in the platform layer. And so what we want to do is replace those calls to output debug string, right, with our own way, our own font overlay system. So in order to do that, obviously we need a renderer, like we need to be able to target a bitmap and all these other sorts of things. So what I'd like to do is I'd like to go ahead and assume that we're going to be past a renderer here, right? One of our render groups, something that can do that rendering, right? So in here, I'm just going to assume temporarily, okay, we're going to get a render group, and the render group, right, is the thing that will do the output for us. And so when we come through here, we're going to want to do basically the same stuff. So what I'll probably say is, well, for now, let's just assume that we have something that's like, render string or something like this, right? And you can pass a string to be rendered. So I want to do a render string. I think we were doing push basically, right? So maybe push text is a better one. Something like that. And so here's my render group. And when I do these debug cycle counts thing, right, I'm just kind of going to push that text on there. The thing that it doesn't really say, it doesn't really specify, is where the text should actually show up, right? So that's kind of a little thing that we kind of going to need to address, right? So we'll talk about that in a second. But for now, let's just assume that we're going to have some way of dumping that text. We loop over the counters that we have, and just like before, we just check, if this counter ever got hit, then what we're going to do is we're going to print it out. We don't have any way to do this yet. We don't have a way to do this sprintf because that's, again, a Windows platform thing that's happening there, a CRT Windows sort of thing, and we're trying not to use any libraries in Handmade Hero, so we don't want to call that. So what I'd rather do is I'd rather temporarily say, okay, until we have a replacement for that, what I'm going to do is assume that text buffer thing, right? I'm going to assume that text buffer part of it is actually just going to be whatever the debug counter part of it was. Oh, wait, but these don't even have any names, do they? That's kind of weird. I guess we never gave these names. We just never bothered with that, I guess, because we were just doing other things at the time. That's kind of weird. Well, that's something that we want to do, so, we'll just say to do Casey, give these things names soon, right? But we can actually just sort of cheese the names in here pretty trivially, right? All we would have to do is just do something like name table and say, all right, well, we know that these counters all have specific values, so we're just going to go ahead and tell you what the names are right here. Again, not what we would like to do long term, because we don't want to have to be involved in the sort of fussy management of these things. So we'll look for a better solution to that later. There's a lot of things we could do to fix that, but again, not really important right now. So for the moment, we'll just do the super cheesy and not particularly good thing of saying that we'll take the name table and we'll use the counter index that we're talking about, and that will allow us to go ahead and push that string on there. And then what we want to do, again, besides just the naming part, is we would like to eventually tackle the part where we print it out so that we can actually see the values of those performance counters. That's the end goal. Okay. Now, there's the matter of resetting our stuff here, which is not something I want to do in here because this is just the overlay. So we'll still let that reset happen in the platform layer, but eventually, again, that too, a lot of this stuff we're going to start hoisting out because the only reason those debug cycle counters were sort of getting dealt with at all in the platform layer was because that's the only place that we could output them. So as we're sort of, like those of you who've been watching know, in our sort of to-do list situation as we're going through things here, oh, hey, look at that. We sort of finished that one. We're in the debug code section. So what we want to do here is we're sort of going through all this stuff that we need. And so the first thing that we're doing is the fonts, but the idea is stuff like this debug cycle counters. We'll be adding lots of stuff like this over the course of the next few weeks. And we want them all to sort of be nicely contained in the Handmade Hero code proper and not in like a platform layer or anything like that. So anyway, while we're in here, we're going to do these push texts, and then eventually we'll sort of tackle this guy. But for now, this will just do that kind of simple printout thing. Now, like I said, what we don't quite know here is we don't actually know where those text things go, is the thing, right? We don't actually know where those are being sort of pushed. And, right, because normally there'd be like some coordinates here or something like that. Now, what we could do, obviously, is we could introduce something here where I have to start specifying coordinates and all that stuff. But that's not particularly good because if we're talking about debug code, I don't want to have to spend a lot of mental energy or pass a bunch of things through my code in order to do debug printouts. So what I'd rather do is make it so that the thing that draws fonts in the engine for debug stuff is actually like pretty clearly labeled as such. So instead of a push text, I'm going to go ahead and say that we have something else, which is kind of like a way of saying that I'm doing like a line of debug text, right? And then I'm just going to expect at the moment, I'm just going to expect that the render group has these debug services built into it, so it just knows that every time I output a debug text line, I kind of just want them to like feed down the screen. And later we'll kind of maybe augment that with some better ways of saying what gets categorized in different ways, so when we have too much of this stuff, it doesn't just kind of overflow things. But at the moment, like I just want to start basically with that. Whereas if we were doing something more for graphics work, which we will do a little bit with our fonts because we're probably going to display strings once in a while in the actual game, right? That would be something that we'd want to do with coordinates, like put the text here. So what do I want this debug text line to look like, right? So if I go into Handmade Render Group, you can kind of see here that we've got this render transform. And the render transform is clearly something, right, that's going to be used to do the actual rendering for the game at that time. So what I want to kind of introduce separately is maybe like a render transform that is used for debugging that's separate, right? So it's not using the same one as for the game. It's using like a separate render transform that it does in a completely different way or something like that, right? And furthermore, I'm thinking that probably what we would like to do, essentially what we'd like to do is have a whole nother render group that's just for debug stuff, right? And I wonder too, now that I think about it, I wonder too if we want to just make that render group be implicit. It's some kind of global variable that's always available for debugging. You don't have to pass it around anywhere. It's just there's a way to get it. Because since it's only for debugging, and we will be trying to compile it out, at the end of the development cycle, I do wonder if maybe that's not an easier way to go, because we want everyone to be able to access the debug services no matter where they are in their code, whether or not they've been handed a render group, right? So I'm thinking maybe what we really want is something more like this, where you can kind of do the debug text line thing, and that just kind of has a magical global that it always knows it can get at. That's going to allow it to get its debug information properly displayed. So I think I like that a little bit better. So I think I like it so that we can just kind of pass the sort of debug text line stuff. We can sort of just pass those directly. And so let's try that. Let's at least try that. So if I am going to have that, then what I would like to do here, right, is I'd like to have something that was like a global variable, which is like a render group, which is like the debug render group. Something like this. And in fact, I guess, if you think about it, it doesn't even necessarily have to be a render group. It could be its own like sort of debug gathering thing. But for now, I'm going to make it a render group because I'm not sure. So we may change that to be something slightly different instead of a render group. You know what? I think just thinking about it in my head, I feel like we're going to want it to be separate because, like, here's what I'm thinking, and I'm not sure. Oh, this is a tough one. This is really a tough one. So what I'm thinking is, suppose we have like lots of code, and all the code has debug output in it. Obviously, you're going to want to be able to pick what debug you're viewing and what debug you're not viewing. So one way you do that is it just gets buffered up in this debug sys thing, and then you can like pick which one you're viewing or whatever. But you probably could do that one in a forward feeding fashion as well, where it's just like it just throws out all the calls that are would be filtered out by the current selection of what you want to view. So we could still do it as something that immediately kind of renders to a render group. So I don't know. It's a pretty tough thing. I guess I'll stick with render group for the moment, and we'll see what happens, I guess, as we go. And who knows? All right. So if we have our debug render group here, then we're just going to assume that when we come into game update and render, that we will sort of initialize that guy before anything significant happens, right? So that there's a place where the debug stuff can actually go to, yeah? And so if we assume that that's the case, then we can take our debug text line. We can say, okay, we've got our debug text line here, and it's going to take a string that's supposed to output. And what we would like to do now is we would like to go through and convert that to actually drawing stuff. Now we know how to draw strings, right? Because we kind of have our nothings fountain happening here. So we kind of know that we can draw text this way already, just using the rudimentary stuff that we kind of pulled out before. It's not particularly pretty, but it works, right? So let's start by doing that. We'll start by using that exact same thing. And what we can do here is say, okay, whatever the value in the string is, that's the Unicode code point that we would want. We'll still make these match vectors here. So we'd initialize those match vectors, and we would say that we want to loop over the string, sort of getting the best match bitmap from each, right? So yeah, so we set the tag Unicode code point weight to something. We would then loop over the string. And as we loop over the string, we look for the bitmap that corresponds to each individual setting. So to do that, again, also we would need the assets in order to sort of grab those asset bitmaps, which would also, now that I think about it, I feel like the render group is always supposed to have that in it as well. The assets are actually right in there, right? So really this could just be debug render group assets, right? Like so. So that's how that works. That would get the bitmap that we actually need. And similarly, we should be able to actually push that bitmap now using the push bitmap call, right? So push bitmap, here we go. And that's pretty basic. It's just like how big we want the bitmap to be, and then like, where we want the bitmap to be, right? And that's really about it. So there we go. And I guess we also technically have the ability to colorize it, so we might as well. Okay, so when we do this push bitmap, right, again, this is just really pretty basic. We're not getting very far here or anything like that. We're just kind of doing the really, really simple stuff. I'm just trying to get some minimal thing working. Let me go ahead and compile this to see where we're at. Let's see. Is it not global? Is that not the name of our thing? Let's see. Internal. Global variable. There we go. So let's see. Render group does not have an overloaded member function. That's true. You are correct. I guess what I could do though is actually just make one here. Render group equals debug render group. And then do that. Okay. So that would actually output all of the bitmaps, not in any particular place and not at any particular size of use to anyone, but it's getting us started. Okay. So let's see what we can do here, if anything. So in here, what I'd like to do is at the very end of everything, when we get all the way down to the bottom, right? What I'd like to do is, I guess, perhaps even outside the time block. I'm not sure. That's kind of a good question. But I want to overlay those cycle counters on here and see if we can't get them to sort of do something overlaying our system, right? So if I call that, what should happen now is we should crash or assert right away, right? Because we haven't initialized that debug render group, right? So if I run it now, as soon as anyone tries to do anything, right, in here, this is just, we haven't set it up, right? So in order to get this to start working at all, the first thing that we're going to have to do is we're going to have to set up that debug render group. So if we wanted to set up a debug render group, what we need to do is we need to have some memory for it, right? Because we don't have anything like that at all. And so if we take a look at the render group itself, when we initialize a render group, right, this stuff can all just live in the global, right? Like all this stuff lives in the globals, but it's this push buffer that actually needs space, right? The push buffer has to exist somewhere for the debug render group. So when we do our allocate render group, you can see that what we do is we have to pass it an arena, and then the arena it will actually allocate its space from, right? Like that. So you can kind of see how that goes. And in fact, the render group in this case is actually like it returns a pointer because it'll allocate into that arena. It'll actually allocate itself as well. So yeah. So I guess that means really we could just do it like this. We could do something like this. If we've got the debug render group, then use it, kind of a thing, right? And that would certainly prevent us from crashing, but it's not going to help us overlay anything. Again. So right. So that's fine. So what we'd like to do now is we'd like to actually initialize that render group. And so what we want to do is when we first start up, I guess we want to just steal a little bit of space from, say, the transient arena, where we can initialize that debug arena and have it actually work, right? So what we'll do is we'll say debug render group equals allocate render group. We'll throw it some memory from the transient arena, and then we can go from there. So handmade render group, it needs an asset system too, I guess, so we probably want to do it like this, where we know that we'll actually have some assets. We don't really know what the push buffer size should be. We're kind of just making stuff up, and we'll go ahead and say that this doesn't render in the background because, well, it's not gonna render in the background. So anyway, if we actually get that, now our debug render group should actually do something. Of course, the interesting thing about the debug render group, right, is it's not actually going to do anything until we actually call render group to output, right? And so if we want to, at the end of this, after we do our overlay cycle counter stuff, we can come in here and do render to group to output with our debug render group. So we can even do something like this, where we say, you know, if there is one, we would like that to happen. The output target should still be valid, oddly enough. I don't actually know. Draw buffer. And presumably, we can just slap our stuff right on top of the game surface, right? By just saying, hey, render on top of the thing that was already there. Presumably. Now we have a problem, which is that when we do render group to output, you will notice that when we call that, we don't actually have excuse me. And I guess we could even do it tiled if we wanted to, right? We could do this threaded. I'm not sure which one we want to do, but either one would work, right? I don't know where is the render queue? I guess it's the high priority queue. So there we go. So yeah, we can do this tiled if we want to, and all that. But basically, what's going to happen at the end of this, this finish render group thing that we call, which does that sort of the end generation bit. What's interesting about this is the render group itself would need to get recreated at this point. And to some degree, we don't actually want that to happen, right? We would rather have it so that we can have a render group that we can kind of reuse, I feel like. And so what I'd kind of rather do is have, like, you know, something like begin render pass or something, or begin render, you know, and end render. Something like this, where when you call begin render, that's when it actually does a generation ID, you know, something like this. And then, you know, maybe it asserts even, oops, assets, that's good. Maybe it asserts that it's not doing that, so it doesn't assert. This equals 0. And then when you end render, it asserts it's not equal to 0. And we could make it so that the asset system doesn't generally return 0. I don't know. Probably can't always do that, so we won't actually say that that's true. But we can certainly assert this one, right? So anyway, if we do a begin render, end render, then that will all work nicely. And the only thing that we would have to do to make this reset itself, because remember, if you take a look at this, the only thing that actually tracks where we are in the render group is just the push buffer size, right? So if we wanted to, we could just reset the push buffer size to 0, and now we've cleared the render group and can just use it again, right? So we could just do an end render here on the debug render group, and everything is magical and fine, right? And as long as we do a corresponding begin render before we start, everything, again, just peachy. You know, it's kind of like it's peachy. And so we would have to do that again immediately after initializing the transient arena. So that's, you know, we'd want to start the rendering like so. But off you go. And we could also make a Boolean here even for debugging, which, you know, I mean, we could do something like this, inside render, like that, and say, you know, assert group inside render, and inside render. So we could just do something like this, right? Where we say, okay, assert that you're not inside a render, and then now you are, right? And similarly here, assert that you are inside a render, and now you aren't. Something like that. You know what I'm saying? And furthermore, the other thing we could do is anytime anyone tried to push to something, right? So, you know, if we took a look in here at like push render elements, we could just make sure that anyone, whoever tries to do this, we just assert that we're inside, so that no one can do it outside of one of these passes. And you know, just giving myself a little security buffer, right? Just trying to give myself a little bit of a safety net in case I make a mistake somewhere. Okay. Same would be true for all of this stuff, right? Just making sure we always have you know, a render group that's been properly set up. So okay. So suppose we do that, right? Then when we do begin and end render for the render group, we could just keep rendering to it and reusing it over and over again, which is kind of nice. And that's all good, right? So let's see. Inside render here, off the wrong pointer. There we go. Same with this guy. And so now, for these dudes, right? When we do our allocate render group, we now need to do a begin render on the render group, right? Like so. And now this turns into an end render on the render group. Yeah, finish render group, same thing. This is going to be an end render. And then up where we did the allocate, we're just going to do a begin render. And now we have the option of saving this as well, rather than allocating it every time, which we might want to do too. Kind of up to us. Okay. Let's start. Oh, so is that, that may not be initialized as well, is the other thing, right? We didn't actually initialize that in our allocate, which I should do. There we go. So in here we want result in render equals false, so that we know we are not starting inside a render, certainly. Okay, so that's all fine. Now what we need to do is we need to actually start setting up our render group so that the render group will, you know, be able to display the bitmaps, be able to display the debug bitmaps. So what I want to do first is create an orthographic display. Now remember, there are two types of ways of transforming that we talked about on Handmade Hero: perspective, where things that are further away get smaller, and orthographic, where they don't, right? And so for our debug output, we just want things to be orthographic because we're just trying to make like a flat overlay on the screen. So when we initialize our debug render, we want to set an orthographic render group here so that we're just flat drawing to the screen with nothing weird happening, right? So if I set an orthographic display for the render group, we know that our screen has a particular size, right? I guess I don't know at this point whether the screen has actually been set, like the draw buffer itself has been set. It probably hasn't, so I think I want to use buffer directly there, like so, right? So we've got buffer width, buffer height, like so. And then we've got our meters to pixels. Meters to pixels, of course, is a little bit weird for these purposes because now we're not really thinking about any kind of real world units. But if we have a meter, how many pixels should it be? You know, we can pretty much pick an arbitrary thing. I don't know, let's say 100. Depends on how we want, how scaled we want our orthographic text display to actually be, right? But that's about it. So let's see what happens now. You can actually see right here, that's actually drawing to the 0, 0 location a bunch of the font stuff, right? So we're already seeing the results of that debug render. You can see that happens even before I launch a hero, right? So those are just the, you know, the sort of the letterings that we're talking about there. Okay, so the next thing that we want to do is actually get those displaying in a way that looks more like an actual usable font. The other thing that we don't really know about here is in terms of like what we want these actual sizes to be. I don't know. We'll have to think about that a little bit more. But let's press on a little bit first just so we can get more stuff happening before we try to make any of those decisions, right? So if I want to display this debug text line here, then what I want to do is I need some way, like this is just drawing them all at 0, 0. I need some way of actually sort of drawing them across on the screen, right? I need them to line up as letters. So I'm just going to introduce like a variable here at x, and that's just I'm going to move it like, you know, from left to right as I draw letters. Pretty straightforward, right? So if I put that in here and I just, you know, and I was to add something to the value here, then what I could do is say, okay, you know, how big are these guys, right? There's some kind of scale value. I don't know, they looked like way too big before. So I've got some kind of scale value here, right? And I'm just going to add whatever the scale value is. And, you know, if you figured that that scale value was somehow related to the bitmap, we'll figure out how much we should advance by in a second. So there we go. Hey, look, we're starting to get some debug text in there, so that's pretty good, right? But you know, it's in the center of the screen, and it being in the center of the screen is not really what we want, right? That doesn't help us super much. So what we would probably rather have is some way of like having it start to display itself like up in the corner. And furthermore, every time we get a new one, we'd want to move down to the next line, right? So what I'd like to do is say, oh, okay, I've got an @y variable as well. The @y variable I'll advance every time, you know, we get to a new line of debug text. Now, what you can tell though is that since this is just a function that renders a single line of debug text, I don't actually know when that happens, right? So at that point, we need some additional piece of information here. And hopefully you can kind of see where this is going in a second. We'd need another variable, right? We'd need an @y variable here to store whatever the y line is. And we would need that to actually reset itself every time we restart, every time we move to a new frame, right? Because otherwise it'll just move up right off the screen and that would be the end of it. But at the end of this, right, we would know, okay, we just got to move down a line, right? Actually, I guess since y goes up, we would move, you know, we'd subtract to go downward, right? And so what we would need here is we need something like internal void, reset, or like debug reset, or something like that, right? And that would have to reset this @y equal to 0. Because if we don't do that, right, just so you can understand what I'm talking about here, if we don't do that, then it just runs off the bottom of the screen and we'll never see it again. Like it's already gone before we even start. Before the even assets are loaded, it's gone, right? So we need something that's going to do that reset for us. And so we know, right, we know when that would be. We know that at the end, you know, sort of when we're all done with everything and we do this end render, that we could do our reset here and it would clear everything out. Now we could also do it at the beginning. It depends how we want to structure it. But there we go. Right? Now, we're getting closer. We got to move it up here. And also, you may notice that we get a bunch of Z's in here. The reason for that is we haven't put, this is kind of the fun part of about our asset matcher, is like, we don't have any lowercase letters. So it just thinks like, oh, I should just get the closest ASCII to that. It doesn't understand lowercase and capital letters. Maybe we should make it do so, and it knows to just get the uppercase version of something if it can't find the lowercase, right? But we're getting closer, right? We're getting closer to a font. So, okay, so probably, right, that scale value, it looks like it would need a little more spacing. You know, it looks like maybe it needs something more like that in order for the line heights to be correct. There you can kind of see they're a little bit better, maybe just even a little bit more, something like this, right? And so there, that's a better looking debug display there. And so you know what? What the heck? We're having a little party here. Why don't we just go and have it include the lowercase letters too, right? Because right now we don't actually do the uppercase letters. So when we do the glyph extraction, I don't actually remember how we even did this. It's in here somewhere. Let's see, there it is, right? And so if we were doing this here, what I'd like to do is make it so that we have more stuff than just those. And so I'm going to go ahead and say we've got something like, you know, U32 char range to like something like this. And then we do, you know what I'm talking about. This sort of thing. Right? Just making a little thing so I can output a bunch of ranges of characters. And we don't have any punctuation in there. But, you know, we could look at the ASCII table and see. ASCII table. And, you know, and if we look in here, right, the ASCII table is, of course, we've talked about it multiple times in the stream. It's basically a numeric table that says what the numbers are that correspond to the letters, right, that we care about. And so if you take a look in here, you can see that, like, we really don't care about most of this stuff. We don't need carriage returns or cancels or file separators or whatever these things are. Who knows? All we really need is this stuff over here. And so if you take a look at what these are, like 33, so, you know, exclamation point. If you look from exclamation point, honestly, we probably just want everything that's in there all the way up to tilde. So what I probably could do is I probably could just not even bother and just do that, right? And that's probably fine. So let's give it a shot and see how that works. Hopefully it works okay. And so if I run test asset builder on this, presumably now we'll get a little more lettering. There we go. You can see it all nice there. And yeah, that's exactly what we wanted. Debug cycle counts. Oh, for space, yeah, we don't have space. Now, I don't know that we want to actually store a glyph for space because we know that it's not there. So I think probably what we want to do is actually just special case space because we don't need to ever actually draw it, right? So that seems like what we would want to do is something more like this. You know? And that way we, you know, actually get spaces in there properly. So there we go. We've got some fonts. So next thing's next. Let's move that guy up to the corner, which is something we wanted. And then I think we'll be ready to start talking about font metrics because there's a bunch of things, as you've already seen, that we would want to fix if we were trying to make this font output actually look nice. So, what do we want to do here? First of all, like I said, got to move it up to the corner. So in order to move it up to the corner, I need some way of initializing at x and at y to actually be something up in the corner. And that to me suggests that the debug reset wants to go up at the top, right? Because that's sort of where it would actually set that up, right? So somewhere in here it would do that. And maybe we include sort of, with that debug reset, we sort of include the orthographic in there, right? And so what that would do is it would take maybe that buffer width and height, right? So we'd have with it the width and the height, like so. And that would give us probably buffer width, buffer height. What the information is that we actually need to move things to the corner as well, right? Because if we do that orthographic, we now know that this is the width and height of the thing, and we know that this is the meters to pixels, right? So what we could do is we can set at y, right, if we do meters to pixels, right? And in fact, when you think about it, meters to pixels, if we just set that to 1, meters is really not meters, it's world units, right? It's just the units we're passing in our stuff as, which happens to be meters everywhere, so that's why we call it meters to pixels. But we could say that we just wanted pixels to pixels, right? So we could just set this to 1. Then we know that the screen is width wide, and we start at the center, so if we wanted to go up to the top, right, it'd be pretty trivial. We'd just do like minus half the height, right? Seems pretty simple. And we could also do a thing here where we said like left edge, right? And left edge we could set as well. I don't know why I'm bothering to set these to 0. There's no point in that. But you can imagine doing left edge here, and left edge is what x would get initialized to. So that would allow us to move it as well. So let's take a look at this. Let's get this working first. Where's my text? Where's my text? Of course, the scale is totally going to be wrong now. Right? Because if meters to pixels is 1, then it's like a single letter is going to be like huge, right? Is that correct? Meters to pixels. So, assuming we actually wrote the code right in the renderer, right? So if we have meters to pixels, right, then meters is what we're inputting things as. So if we said that we wanted something to be 1.0 high, right, then what that means is it would be 1 pixel high. So I'm assuming that what that means is that our scale would now be drastically small. So we would actually need our scale to be much, much bigger than it was before, right, in order to make it the right size. Of course, we still don't actually see anything, so that's not a good sign. I'll also make it so that we're not actually initializing at y. Take first things first, right? There we go. Okay. So there is everything. And I want to also see, I'm going to lean on the loop live code editing a little bit here. I just want to see what happens when we change this scale, right? So if I change the scale, does that do anything? It does. So that's good. However, oddly, it doesn't seem... Like, how is it possible that it goes away and then comes back? That's a bit weird, right? Wouldn't you say? Ah, although I suppose the loop live code editing, because it's a global, we can't actually use the loop live code editing for stuff in a global. So that's, But there we go, so it does scale properly. So I wonder if we can, it wouldn't be too hard to just kind of to move that around, right? It would be relatively straightforward for us to fix that, and I feel like we should. And the other thing that I was going to say here, so I was kind of leading up to wrapping these guys. So fix this for looped live code editing, because I'd like to do that as well, and it's pretty simple for us to do, so I think we want to do that as well. But I won't do that quite yet because I was kind of leading up to some things there that I wanted to do, and so I don't want to disrupt that train. Point being, scale works fine now, so that's good. We're going to leave it at 20, which I believe would be about 20 pixels, right, tall, and that looks sort of right. So what I want to do now is I want to figure out a way to move at Y up properly, so when it gets reset, it would actually use, again, half the height and move that up to the top, and that way when it comes it would move down. Now I guess we're actually moving up that far, so something like this, and there we go, we're up there now. Of course it's a little bit off the screen because we're moving half the height and then we're drawing at the centroid of that thing. So really it's going to be that, you know, plus the font scale or something like that, right? So if I have a thing up here where I was like global variable font scale, like so, and I say, you know, font scale equals 20, or something like this, then I would want to kind of move down by half the font scale as well, right? And that would line me up with where I wanted to be. Okay. So there we go. Now we're at the top of the screen like we want it to be. And similarly, I kind of want to fix that left edge nonsense, but this is going to be the exact same thing, right? It's just going to be subtracting away the width to get us to the edge, and then adding back in like 1 character's worth or whatever to get us to the left edge. And so then, you know, we should be in the right place. Or not. Oh, whoops, at Y. I meant left edge. There we go. Okay, so now we've got roughly what I wanted happening, right? We've got it lined up where we want it, and we've got it printing out where we want it. But there's a ton of things that we don't have, that we want, right? So even before we talk about how to get like the numbers and stuff in here, we're ready to start talking about the font part. There's a number of things that you can see. I think I might leave them until tomorrow to point out, because since tomorrow is the day when we'll be addressing all of them, it seems a little weird for me to point them all out now. But point being, you can see like lowercase letters are as tall as capital letters. It's mono-spaced, so things that are like small, you know, have the same amount of spacing in between them. All sorts of stuff is not what we would want here. So even though we're getting a little bit further, there's a bunch of stuff that we want to do, and so tomorrow we'll start tackling those metrics a little more specifically. But hopefully now you've seen it's pretty straightforward how the debug text stuff would actually work, and off we go. Now there's another thing here, which is this is too slow for text at the moment. So we also want to think a little bit about the fact that calling this best match bitmap from every time is not perhaps the best idea, and so that's something we want to think about as well. But that's about it for today. I think we're just about out of time. So I'm going to go ahead and go to the Q&A because we're at a good stopping point, and tomorrow we can tackle all of the stuff we actually want to do to turn this stuff, which as you can see is just me writing the simplest possible thing and getting it to the point where it's working, turn this stuff into a more useful system. First of all, addressing some of that, but also all of these things in here, they're just these hard-coded constants. How do we start moving those into the font system so that we can get that information from the fonts, right? That's what we'll be doing tomorrow as the next step in our font metrics exploration. But I'll go ahead and go to the Q&A now. So if you have questions, now would be a great time to ask me them. Put a Q colon in front of it, and I will be able to see it. If you don't put a Q colon in front of it, well, it will be lost to the sands of time. Kalimian, will you be addressing the subscript, superscript, n space, m space, and other types of space tomorrow as well? Probably not. So Handmade Hero will not really have any typography in it. It is not a typography kind of thing. So we will not be doing any advanced typography. Like we won't be caring about like whether left and right double quotes line up or any of that sort of stuff. That stuff is not particularly hard to do, but it's not relevant because pretty much almost all the Handmade hero text is going to probably be debug text. There's not going to be a lot of text in the game. So if this game were about text, well, you would want to spend a lot of time on your typography. But since we are not doing that, I won't be writing any of that. However, hopefully you can see, just from what I've done so far, there's no mystery to it. If you want something that's going to be subscript, well, you just need to move it down, right? And if you want it to be subscript and smaller, you move it down and you change the scale, right? So there isn't like anything magical about fonts. They're just bitmaps like everything else that you're drawing to the screen, and you can manipulate them exactly the same way. And so if you want different space sizes, different dash sizes, that sort of stuff, there's no mystery to it. It's just putting bitmaps next to each other. And so really the only thing that differentiates fonts from everything else is the lookups that you have to do because you're trying to translate some kind of encoding of like streams of them. So there's like the Unicode to glyph thing, like there's that, right? And then the meta information that you need about how you want to do that lining up, like where should a superscript character go versus subscript character, how much kerning should there be between two letters. But otherwise, there's no mystery to it. You can just get in there and any font effect you want, it's just like writing anything else we've written on Handmade Hero. There's nothing magic about fonts. Brain Cruiser, will you add edges to the font? You mean like an outline? I wasn't planning on it, since I don't know that we would want that for anything in particular, but is that what you mean by edges? I'm not sure what you mean by edges, actually. What's the difference between making a game in C++ and making a game in Java? Well, C++ is a language for writing code that gets compiled into actual x64 assembly language, or machine code, I should say. And so, you're running a game directly on the hardware when you write it in C++. Java is a language that compiles to a virtual machine, a virtual bytecode. So it never actually does that. And it's about telling the virtual machine what to do. And then typically, because that's obviously very slow, typically what happens in Java is you then have a thing called a JIT, which is a thing that takes that code and turns it into like x64 assembly, when you're actually trying to run the game and that sort of stuff. And I mean, you probably could do precompiled Java as well, right, if you wanted to. That's not typically how it's used, but you could do it that way. Of course, Java doesn't actually allow direct memory access and stuff as much. It's more about, it's more about having references to things and this sort of stuff. And it's not really about sort of manipulating bits at the low level. That's not what they wanted you to do with it. Although, again, like everything else, there's always some way eventually to make it happen if you really wanted to. So making a game in Java is mostly, it's usually something reserved more for people who are trying to do sort of less low-level programming, even though, honestly, I don't know. I don't want to disparage Java too much because I don't program in Java, and so, I probably shouldn't diss something that I don't use. But on the whole, honestly, I don't really know what the point of Java is. It's not a good high-level language. It's higher level than, C, but it's not a good higher level. It's just arbitrary. It's like it introduces this annoying VM that doesn't do anything good for you, and it doesn't have very powerful language constructs. So, I don't super understand people's decision when they decide to program in Java. It doesn't make a whole lot of sense to me. I would say if you're going to go with a high-level language, I'd pick something else. There are better higher-level languages out there, I would think. But for me, I like the lower level, the better usually. So I prefer C and C++ because they give me a lot more control over what's going on, and I don't have to worry about what how the pipeline goes from like my Java code to a VM to the JIT to the execution. Like none of that. I'm in control. I don't have to worry about all these sort of other things that I don't have control about. Brain Cruiser, yes, outlines. I wasn't expecting to add outlines to the fonts. Is there? I mean, if you want to add outlines to the fonts, then it would be a bitmap operation you'd probably do there. Or you'd have to go do your own TrueType like line rasterization, which you could hack into like SDB TrueType if that's what you really wanted to do. Robbie, hi Casey. Question on the array you typed and pulled out again. U32 char brackets brackets 2. Is this an array with pairs of U32s? Yes, it is. I would have expected U32 brackets brackets. Oh, so in C, you were talking about this part right here. Then I realized I didn't have to do it. But in C, the way that you do an array or a 2D array, right, is you keep stacking brackets on. In fact, you can do as many as you want, right? And the way that they work is it starts with the furthest one out. So for example, if I had this many, and I did something like this, right? Although you wouldn't have an array of 1, but you get the idea. So if I had something like this, what that means is the first array in the rightmost array index, right? This one right here is the one that increments in memory by the smallest amount. So effectively, if you were to look at these U32s, well, heck, I can just show you. So in here, I'm going to make this array, right? And then I'm going to do some stuff to it. So here, let's clear it. And then I'm going to do some addressing into it. Right? Okay. So I'm going to look at, in each case, I'm just going to go 1 unit along each of these guys. Right? Does that seem reasonable? And there we go. So in fact, I guess I could just do it this way. A, B, C, D, E, F, right? So the way this works in C is this is the ones that are closest together, is at the rightmost edge, and this is the ones that are furthest apart. That index will move you the furthest apart. So this is like saying I have an array of 7, arrays of 6, arrays of 5, arrays of 4, arrays of 3, arrays of 2, uint32s, all the way back to the other end, right? And so if I compile that guy down, and I set a breakpoint there at the debug text line, right? We can see the array in memory happens like so. Oops, that didn't work. Come on. Why? Why will you not copy? Copy my value. Copy it. I do not know why you will not copy my value. Fine. OX3159A0. There you go. Happy now? Fantastic. All right. So if you look at me writing into this guy, this will write in an A to that location. I don't know why that did not show up. You did actually go there, did you not? Find A0. There's my A, right? Right there. So these are U32s. You know what? I should probably do them as U8s just so it's a little easier to see. There we go. All right. All right, one more time. How come I'm not, like, what's going on there? Does anyone know why it's doing that? Why I can't drag that value down? It's weird, right? So there's my A. And you can see that I have a 1 here. So if this was a 0, it would have put it right here. But because I said move 1, you know, on the lowest index, it moved it 1 byte over. So these are basically sequential, right? The lowest index is sequential. The next highest index up is going to be by however many this one was, right? So this is 2 bytes each. So moving 1 on this guy will move 2 bytes each time, right? So now we would expect it to move 2 bytes forward, which would be like over here, right? Make sense? Now this one's going to move 3 times 2 bytes forwards because it's moving 3 arrays of 2 forward. So that's going to move 6 forward just by an index of 1 here, right? 1, 2, 3, 4, 5, 6, right? And there you go. And then let's see, where is this guy? This is 1. So this is going to be 5 arrays of 4 arrays of 3 arrays of 2. So that's 5 times 4 is 20, right? That is the one we're doing, right? Yeah. So 5 arrays of 4 is 20, times 3 is 60, times 2 is 120. I don't even want to count that. It's going to be down here somewhere, right? In theory. Let's see. 5 times 4 times 3 times 2 is 120. So where is the array at? It's at A0. That seems 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That doesn't seem right. Oh, I'm off by 1. Because of this thing. I'm off by 1. It's only the 4th one up. Okay, good. I was like, what's going on? So it's 4 times 3 times 2 is all it was. So that's it. 6 times 4 is 24. So that's totally fine. Right. Now it's the 120. That one should be down here. There we go. That could reasonably be 120. I could buy that. And then this one's going to be 6 times 5 times 4 times 3 times 2. So who even knows what that is? Something way down there. Right. So that's how those are read. In general, the way that you read a C declaration is pretty bizarre. It's always go as far right as you can first until you hit a parenthesis or the end. Go as far left as you can till you hit a parenthesis or the end. Repeat this process, right? I know what I said sounds weird, but that's what it is. It's go as far right as you can until you hit that. Go as far left as you can until you hit that, right? That's how you read them. So if I say array this, then I have, well, we'll get things a little simpler here. If I say array that, I've got an array of 3 arrays of 2, and now I've hit the end. There's nothing left. So imagine there's an imaginary parentheses at the end. So an array of 3, arrays of 2. Then I start over going to the left, U8s. So this is an array of 3 arrays of 2 U8s, right? Start at the name, go right, right, can't go right anymore, back to where I was, go to the left, done. These can get very complicated, and you can make all kinds of ridiculous stuff. For example, what is this? Anybody know? Well, it's an array of 3 arrays of 2, got the end, pointers to U8s, right? So this is an array of 3 array of 2 arrays of 2 pointers to U8s, right? But what is that? Anybody know? Just do what I said. Start in the name. It's, array, or I should say something like foo. Foo is. So foo is it an array? Not yet. Foo is, I hit a parentheses. So now I go backwards. Foo is a pointer, right? Now I hit another parentheses. So now I go to the right again. To an array of 3, keep going to the right, array of 2, and I hit the end, go back to the beginning, U8s. Right? You want to make it more complicated? Go ahead and make it more complicated. Let's parenthesize this. Right? In fact, we can make it even more ridiculous. How about that? How about this? Right? Now we've got foo is, hit the right paren, go to the left, got the pointer. Oops. Come back. What just happened? What just happened? Okay, there we go. Foo is, go to the right, hit the paren, go to the left. Foo is a pointer. Hit this paren, go to the right, to an array of 3, hit the paren, go to the left, hit the paren again. I guess we have a redundant set of parentheses there. That pair, I guess, doesn't really need to be there. You can get rid of that, right? To array of 3, hit the right paren, go back to the U8, 3, U8s. And this whole thing is an array of 2, right? There's 2 of that whole thing. So 2 is an array of 2 pointers to arrays of 3 U8s. Who knows? Why would you have that? I don't know. But you can have it if you want it, right? So that's, you know, that's what that is. Happy birthday. Foo undeclared identifier. What are you talking about? Why are you grumpy about that? Pointer to an array of 3, array of 2. Why don't you like that? I feel like I should be able to do that. Maybe I can't. I feel like I should be able to do that. Maybe I actually can't. This is not a variable declaration style I would ever use, but foo is a pointer to an array of 3 U8s. I guess you're not actually, now that I think about it, that's actually not legal. You can read it, but you can't actually write it. Because that completes the definition already, and you can't really add the array of 2 in there. So if you wanted to do the thing that I said, you'd actually have to put the 2 there, if that makes sense, I think. So that it would be like foo is an array of 2 pointers to arrays of 3 U8s, right? Like that. That's the only way you could actually do that declaration. Because once you actually wrap it up, you're not really allowed to then make that be a 3 thing again. Not sure why. I guess that's just because the way the C parser is written, it doesn't have the ability to take that for whatever reason, right? It's like it can't handle you wrapping the type up in there because array subscripts in the parser have to be parsed before the final type of the thing. So when you actually do that, I assume you kind of would need another type there, right? Something like that. And of course you can't, that doesn't actually work. So they pretty much only allow you to actually put the array subscript in there. I don't know how I got off on this tangent, but point being, that's how to read C declarations, if that makes any sense. Will you implement colored text? Well, colored text is just, you can just tint it using the renderer that we already wrote, right? So if you wanted the text to be colored, you know, if this is what's happening currently, where it's white, if you wanted to color it, you can just say, oh, you know, you wanted red. You just change the color that you pass to the renderer to be red, right? And then it's red. So, because that we've already gotten color modulation built into the renderer, so you can just pass it. If you're passing it a white bitmap, it's free to just color change it. Cuber Caleb, do programmers actually use that crazy array semantics that you just said? No. As evidenced by the fact that I accidentally constructed something that you can't even actually type in C. I never type anything even remotely that complicated. It's just I happened to remember how to generally read those because sometimes you have to. But I mean, to say the very least, your goal should be to never have to know that stuff I just said. Because if you actually, it's more for reading other people's code when they've done something crazy. I never, you know, hopefully you never do that. use some type defs or something if you have to. Insofar as you didn't answer the bit about how if the color info would be embedded in the text as control codes. No, that doesn't sound like fun to me at all. You're talking about basically like just putting, I mean, I guess if you were trying to write like a text editor or something, but I don't know why. I mean, you can always just, if you want to, you can certainly have a thing where in here you parse and see if you get something, right? Like if you wanted to be Mr. Does ridiculous stuff all the time, you could do something like, oh, you know, if, you know, I do this, then I'm going to change the color or something like that. I mean, it's really, really straightforward. If you want this, you can do it. It's not my jam at all, so, you know, I wouldn't be something I would be doing, but you certainly can, you know, you certainly can do it if that's what you want, right? Is that what you're looking for? You know, if that's your jam, go nuts. You know, do whatever you got to do to make yourself, you know, a happy puppy. If you want to, I suppose you could do, you know, some kind of ridiculous thing where like, okay, you know, I saw a backslash in the text or something, and so when I see a backslash in the text, I'm gonna like read out some kind of a like code at this point. So it's like, okay, you know, if the thing is, you know, looks like that, then what I'm going to do is I'm going to assume that at3 is going to be like these are going to be like color values or something. So you know, maybe I'll double check also that, you know, at2 is not 0, just to make sure that I'm not at the end of the string or something, right? So it's like, okay, just make sure that there's a backslash followed by the pound, followed by 3 characters of some kind, right? And so then we just say like, okay, you know, assuming that that happens, then I'm just going to take those 3 characters, right, whatever they are. I'm going to assume that they were like, you know, numbers from 0 to 9 or something. I don't know, right? I'll just assume that they're numbers from 0 to 9, because why not? And that'll just be my color value, right? That's going to produce a number, right? Because the ASCII characters 0, 1, 2, 3, 4, 5, 6, 9, they go sequentially. So if I subtract the character value from 0, I'll get a number between 0 and 9, an actual integer, right? And so then I just want to scale that. I want to turn that to an R32, and I just want to scale that into a 0 to 1 range, right? And so the color scale there, right, is just going to be 1 over 9, because I wanted to convert a number between 0 and 9 to a number between 0 and 1, right? So if that's, like I said, if that's your jam, I got you covered. You're looking at something like that. Probably. I'm guessing. That's like off the top of my head. So then, you know, if you wanted, I don't know what you're thinking here, but if you want something like that, then you're just like, okay, you know, I want red for that, and you know, get some green in there, some yellow. I don't know. Is that what we're talking about? So yeah, pretty straightforward. Obviously, we don't want to print the control codes, so after we eat them, just skip them. Except I forgot that it would skip this one. If you're gonna do it that way, I'd probably go ahead and do that. But yeah. In some object-oriented languages, things can become that complicated. Not sure what that means. Would printing text to a separate bitmap background be easier than putting it straight on top of the game background? I don't know that it would be any easier. Maybe there's some other reason you might want to do it. But yeah. Insofar as nice, that was very quick to implement. Yes, it is. I mean, there's nothing to it, right? It's really basic. How about a 2D array of function pointers? Might have been why a few of those variants didn't compile because it thought you were declaring a function pointer array, star foo. Maybe. Around how many more episodes until you switch from software rendering to hardware rendering? I don't know that we'll ever switch to hardware rendering until like the end. I mean, I would rather always do software rendering. So it's only for speed purposes that we would do the other one. Right. Can you rotate and transform the text? Well, sure. I mean, it's just going through the bitmap just like everything else is, right? So if you wanted to, you could rotate and transform the text. I think our push bitmap call doesn't take one of those additionally, so you'd have to change the transform, right? You'd have to spin it. But obviously, you could do that, right? So you know, if you're in here in the render transform, and you know you've got sort of the offset and scale and stuff in here. Oh, so I guess in our render transform we don't actually use. Interesting. We don't actually put axes in there. So basically, like right now we don't actually expose any pushes for that. So we would need to first actually have a push for that, right? Because right now when we push bitmap, we don't actually push an axis system on there, right? So we need to add that, if that makes sense. Because right now we support it, but if you look in here, when we actually draw the bitmap right here, you can see that we actually just always specify the axis right here. So we need to just grab those axes out of the actual push buffer. That would be the only thing that would have to happen there. Obviously, you can change the scale if you want to too, right? If you want to be Mr. Encode stuff in their code, which seemed like what people wanted to do, you know, you can go nuts, have a party. Right. Something like this. Probably. Just guessing. So, you know, if you want to change the scale, we could change the rotation too, but we don't actually have in the renderer, we don't have the push buffer stuff. All of our rotation code was just in test code. Should probably add some rotating stuff soon, just so we can make sure we never break it. But yeah, I mean, if you want to, like, we could make counts be tiny now, right? Probably. Oops, forgot to actually pass it. There we go. Right. So now counts as a little tiny baby counts. That might be a little too small. Let's be honest. Let's go half size. Right. All right, stream is ended. And if the stream is ended, it's ended, folks. You know? Nothing you can do about that. Let's go ahead and close it down. Close it down. Okay, everyone, thank you for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. We got our fonts going today, but like I said, we kind of just put in some hacked in values right now, which was the goal of today's episode, in fact. So what we want to do tomorrow is we want to now go and look at what those hacked values all were, and then go into our asset processor to sort of start providing those actual values from the fonts themselves so that our fonts will look nicer and be lined up appropriately. That's what we want to do tomorrow. Hopefully you'll join me for that. We'll be right back here at the same time, same place, 5 p.m. Pacific Daylight Time, right here on Twitch. So I hope to see you for that. Until then, if you want to play around with the source code yourself at home, it's pretty easy to do. If you pre-order the game at handmadehero.org, you can download it every night. I upload the latest changes for the day, and you can grab them. So if you want to do that, check it out. And we also have a Patreon page if you want to support our video series. If you like watching the show, please check it out. And we also have a forum site you can go to ask questions on the forums, or if you want to get community resources like ports to Mac and Linux people have been working on, or annotated episode guide that people have been working on. Those are up there. And we also have a tweet bot that tweets the schedule. So if you're trying to catch the stream live, you like watching it live, you like asking the questions, that is the place to go. Subscribe to that or just check it periodically. It tells you what the schedule will be every day. That's about it. Thanks so much for joining me. We will be back here tomorrow. Hope to see you all here. Until then, have fun coding, and I will see you guys on the internet. Take it easy, everybody.